In this tutorial, we're going to go over some of the basics of getting started with Python. We're going to start with how to name variables in Python and some of the allowable ones, some of them that are not allowed, and also Python reserved keywords such as built-in constants. We also have these other reserved keywords, just a basic description of what they do. And so there's a fairly long list there, ones that you want to avoid when naming variables, and then also other built-in functions. We're also going to talk about IDEs and some of the syntax highlighting, run a simple program or two, and then we'll talk about Python objects in this tutorial, Python data types, integers, floats, strings, and dictionaries and tuples and lists. And then we'll go on to math expressions. And finally, we're going to talk about Numpy as well, and math packages and modules, and then talk a little bit about strings and how to put things together. Okay, so this is just a big picture overview of what we're dealing with this. To get to this tutorial, I want you to come, if you'd like to follow along with this, just come to the APMonitor.com /CHE263 website, and then down on the right you're going to see Python basics. The introduction is how to get things installed, so hopefully you already have everything installed, and then what we'll do is we'll go through this in a little bit of detail, and I'll explain some of the things besides just rushing through it like I just did. Okay, so what I'd like to do is just use Spyder for this. You could use Notebook as like a Jupyter Notebook, or you could just use a text file and run it with IDE, for example. But we're going to use Spyder, that's part of the Anaconda distribution from Continuum.io, and it'll check for updates for you, but I'll go ahead and just use this one. Okay, and the very first thing is once you start that, let's go File, and we'll do Save As, and then I'll just save it to the desktop. And I'm going to rename this as basics. Okay, but you can rename it as anything you'd like. It just puts a text file there on your desktop. Okay, so let's just start off with some of the basics here. If you do have my variable, let's say it equals 4, and then you run this, and then you can select where you want to run it. You can execute in the current console. Okay, I'm just going to click Run, and then if I go to Variable Explorer, up here on the right, you can see Variable Explorer, File Explorer. Variable Explorer will show me that I have a variable. It's a type float. It's size 1, and there's the value. Versus if I said it equals 4 without the decimal point, and saved that, and then ran it again with the green button, that it would say it's an integer type, size 1, value 4. Now, if you put anything like number, my variable equals 3, okay, 4, it's going to say that there is an error there. And so one of the things to look for in Python, one of the most valuable things is to look down here at the error, and it's going to put a little caret right underneath where the error is with an error message. Okay, so sometimes you have to look, sometimes it also puts it on the the next line. For example, let's say you times 3 minus 2, and I'm just going to then do my variable equals 5 down here. Sometimes it'll tell you the error is somewhere else where it isn't. Okay, let me save this. Okay, it ran. Okay, so I've got these two that are right here, 4 times 1, which equals 4, and then I have 5. Okay, but let's say I forget, like, for example, the parenthesis right there, and I run it again. It'll say that the error is on this line. Okay, and sometimes you just need to look at the line preceding or the line after. So just make sure when you see an error there that you look above and below it as well, especially for things like missing parentheses. Okay, so let's go on down to our next one. We have some of the reserved keywords, where we have true and false, for example. I'm just going to say this one equals true. My variable equals true. It's going to give us a Boolean or a logic. and there's the value that's equal to true after I run it. Now let's say if we had equals my variable is less than 3, okay, and I run it again, then it becomes false, okay, because I had a condition here which was my variable is my var is less than 3, and that becomes equal to false. You can put a parentheses around that if you'd like to. Okay, but we can also do that with a something like one of these reserved keywords, which is if, and then you can say my variable. Okay, you can put that in there, or you could say if my var is less than 3, we can print less than 3, else print greater than 3. Okay, so then I can adjust this to a different value and run it again, and then it will print less than 3 there. Okay, and you can see some of the variables. This is a very useful, the variable explorer is very useful. You can also do things like put in breakpoints. Double click over here, and then you'll see a breakpoint, and then if you run it in debug mode, then it should go to that line like you see it, and you can kind of step through the code. Okay, so we can run the current line, we can step into the function or current line method, or run until the current function or method returns. Okay, so you can just run it, and you can see that that line is highlighted, and it kind of shows the flow of the information there. If you ever want to stop the debugger, you just click this blue square button and it will stop it. Okay, but it's very nice in terms of being able to step through the program one line at a time. Okay, let's go on. So here are all the reserved keywords. I'm not going to spend time on those. We'll do that in subsequent material. We also have built-in functions as well. There's really good documentation. If you just select that link, it'll take you to a page that has, it talks about all the built-in functions and what they do. So I definitely recommend that, but I put these here just so you'll avoid those when naming variables. Okay. Here's an example of some reserved keywords. As I mentioned before, syntax highlighting, if you have something like this, you can't really see some of the reserved keywords, but if you just paste this in here, oops, I did print screen. Okay, I'm going to delete that and then paste in, I'll copy in this text. And there you can see, the syntax highlighting is often different between different environments, but it gives the same thing. In this case it's blue on the left and Spyder for some of the reserved keywords. So if a variable becomes blue, then I recommend changing that. Here's a constant, for example, in purple, and here's a built-in function which is int. Okay, let me just go ahead and run this one. You can guess a number between 0 and 10. I'll start off with 5. It says it's too high. I'll guess 3, and it says correct. So it'll kind of guide you in, too high, too low, with this while statement while not correct. And then it'll go through and tell you if it's too high or too low, or if it's correct. Okay, so there's just a simple number guessing game. Not necessarily that we're going to go through all the details of this, but just to show you the syntax highlighting and some of the reserved keywords. Okay, one of the important things about Python is it's an object-oriented language, and so every variable or object has 3 things, which are going to be the identity, the type, and the value. So I'm just going to say x equals 10, and then we'll run that. Okay, now you can see that these are kind of left over from prior running of this. You can also restart the kernel if you just want to get rid of those, and then it will get rid of all of those values that are in the variable explorer. Okay, and then if we run it again, we can see there's the name, the type, size, and the value, but we can get a little bit more information about this as well just by printing. Okay, so I'll go ahead and print x. and then print the ID of X, and then print as well the type of X. Okay, and so you can get that from down here. The value is currently equal to 10. This is the address. It tells it's where the computer is storing that. It's kind of like a physical address, your mailing address or something like that. It says, where can I find this object or this value? And then it's of type int. It's a class, and so you have different things that you can do with your objects. Okay, and so Python keeps track of that. Those are the principal things it keeps track of for objects. Now there's different data types. I showed x equals 10 there, but we have let me just go and get this code right here. So when you're getting this stuff, just go down to the bottom right and click the get code. Don't just copy the text. Sometimes there's some weird characters that are rendered through the web page that get copied in. Okay, so I'm just going to copy this one in and then run it, and then let's look at some of these values here in our variable explorer. So we have we have x, which we defined first. That's an integer value 2, so it means that it's just a whole number there, no decimal points beyond it. You have a floating point number, and that's represented by 2.02, and then we also have a string which is equal to 3. Now if we add two strings together like we do here, we print strx, so we converted that integer into a string and then added it to another string which was equal to 3. Okay, that's going to equal 2 and a 3 because you put those two together. Okay, you concatenated the strings, stitch them together, and then here's another example where instead of putting two strings together, we convert the string that we had here on line 3, we convert that into an integer, and then we add it to another integer which is equal to 2, and so that will equal 5. Okay, so 2 plus 3 equals 23 if it's strings, and 2 plus 3 equals 5 if they're integers. Okay, and then we also have a couple other, to be able to store information like in a list or a tuple or a dictionary. You want to use one or the other, if depending on what you need. But if you have, you can also type commands down here into the console if you want to access certain things. Like let's say I wanted to know what A1 is, A2, or A0. Okay, or I could do a slice of those, A0 to 2. It's going to give me two values, just the first two. Or I could say A1 to -1, -1 being the end. Okay, so that's going to be from 1 to -1. And so if I want to go, let's say, include all of them beyond 1, I can just use a colon with a blank after it, and it'll give me all the way to the end. Okay, so that's just different ways to slice your lists, be able to take subsets of those and return them. You also have tuples that are accessed in a very similar way, B0 and B1. We're not going to get into the tuples or lists and why you use one or the other, but sometimes you require one or the other, and there's advantages to using one or the other. We also get into Numpy and some of the lists or arrays that we use in Numpy. Okay, also dictionaries. We can look up a value, for example, n. Okay, and I think we can also do keys. Okay, it gives us a dictionary keys and values as well. It'll give us those values of our dictionary. Okay, so this is a way to look up a value based on a key, used in database programming, or to look up things. A dictionary has a word and then a definition. The first one is kind of like the key, the word that you're looking up, and then you're looking up how that one is defined. So M in this case is defined as 7, and N is defined as 8. Okay, so those are just some of the basic data types that you can use in Python. Now we're going to get into mathematical expressions as well. Let's just get this code right here. This is importing math. Okay, and then in math we can do something like math.sign. And you can see here when you put dot, you can have all of the different functions or values that are available in the math program. You also see the double underscore. Those are kind of hidden variables that you don't typically use. But let's just go ahead and use sign, and we'll use sign of 3.1415. Okay, and when we run this, okay, we'll see that, let's see, I guess I better print this. Okay, print this one. And so you'll see that that's nearly equal to 0, but we had some round off. So let's just see if we can define, instead of math.sign, let's just see if there's a math.pi. Okay, so that's going to be math.pi instead of typing that out ourselves. And then that's going to be nearly equal to 0. So you might be asking yourself, why isn't this equal to 0? And the reason is that we have finite precision with machine computation, and so we have round off errors. And so just due to machine precision, if you have 32-bit or 64-bit running, you'll get different round off errors there. Okay, you can also use Numpy as well. So instead of math, there's Numpy, and Numpy in many respects is more capable, and you can either do import numpy and then do numpy dot sign, and then you can do numpy dot pi. Should give you the same thing. Or if you want to shorten that, because you might be using numpy a lot, you'll import numpy as np, and then you just replace those with np instead. Okay, so that's going to give us a shortened version of this, but the same thing. So there's an example of just importing numpy and being able to use it. Okay, so a lot of different modules that are out there. Here's the numpy module. If you just go to that link, it'll show you a lot of the math functions, but there are many other functions and constants that are available in numpy. Okay, let's talk about strings a little bit. We had an introduction to that earlier, but if we want to put two strings together, let's say for example first name is Tom and then the last name equals Smith, you can use either single or double quotes. Okay, but let's say our last name is O'Leary, for example, where we have an apostrophe there in the name. We can use double quotes right here, so that or we can do something else, which is an escape sequence to get that in there. Okay, and that will be O'Leary. It says, well, that is really supposed to be an apostrophe, not the end of the string. Okay, so if I run this, I'll see that down here I have O'Leary with the okay. Now the other thing you can do is you can also put in a line break, for example. You can do /n, and okay, and then when you run this, okay, O'Leary, and then there's a line break is my last name. Or if you print that out at the console, okay, it'll start a new line. But if you want to make that just a raw string, you actually do want to print out the \n. You can just do raw in front of the string name, and then it will print that out. Just kind of ignore some of those backslashes. So you can do things like, if you get into this situation right here, just use the double quotes instead. Okay, if you want to just return that, and okay, this one should run again. Okay, so another way to include those apostrophe single quotes. Okay, let's go on to just formatting the numbers. you know, if you do something like import numpy as np, and then you just want to print pi, okay, then we're going to get np.py, and that's going to return a certain format with, you know, a number of decimal places. But let's say we just wanted to, you know, we want to try to memorize pi to a certain number of digits, and we want to be able to put that out in a different form. There's this way of outputting your numbers, and so I'll do dot, and then we'll do 100 digits of pi, floating point number, and we'll do dot format, and we'll format our np.py. So this is going to do pi to 100 digits, and you can see that machine precision, just the way it stores it, it only stores it to this many values anyway, and all of the rest of them are 0. Okay, so we only have a limited precision anyway. Let's just see about how many characters that is. It's about 48 decimal points, and then you start seeing zeros beyond that. Okay, so here is how you know, it stores pi internally, but you can put any number of decimal points there. Let's say to 5 decimal points. Okay, we can change that to an exponential form. Okay, we can also change it to a percentage as well, and it'll be able to reformat that in different ways. Okay, so this is a basic tutorial of how to start using Python with, you know, just to review, we had how to name variables and how to not name variables. Okay, we had reserved constants, built-in constants, true, false, and none. And then we also have reserved keywords here. So just the syntax highlighting in any IDE, it's going to tell you, you know, if one of those is reserved just by the way it colors it. So just avoid those. And also built-in functions is just a subset of all of them that are available. Okay, and then we went on to Python objects. You have the value, ID, and type for each object. And there's just an example that shows how to use different Python data types. We use integer, float, string, and then list, tuple, and dictionaries. Those are some of the most common ones. And then we had math expressions, how to create math expressions. You're always assigning the value on the left-hand side. Okay, and how to use the math and Numpy packages or modules. And then a little bit about Python strings as well. Okay, I hope you enjoyed this. There's a lot more material on Python. That's back here on the course website. If you just come here to the right, you'll see, you know, the Python, as well as if you wanted to do some examples, you can go to the homework. We start with Excel, but there's some Python examples there. And there are some of the Python assignments, but there are also solutions which with each of those to be able to check your work. Okay, well, thanks for joining, and we'll do another video shortly.